And so we actually see a profoundly negative effect from eating certain compounds.
Have you shipped your poop to test these? Like you have to... Yeah,
we just did a clinical trial at Supergut, by the way, and we found, and we published it, so it's public.
But wait, just the audience doesn't even know this stuff exists in all likelihood. You basically take a poop and you put it in a vial and you send it and they analyze your poop. I don't mean to be graphic here, but have you done this before? How does this work?
Yeah, I do it every year.
I've done it. Yeah, and I think it's look, here's the issue, Jason. I want to say two things that I think are really important to say. Number one is we know very little about what bacteria do what in your gut. Which we're starting to understand which ones are beneficial, which ones make good chemicals that your body uses and regulate your cells and regulate your health. And remember, we have a symbiotic relationship with the bacteria in our gut. They're making chemicals and they're eating chemicals. The chemicals they make affect our cells. The chemicals they eat affect our body. So the way that we evolve our health is actually profoundly affected by our gut biome. So we don't know enough yet to say definitively, this bacteria is good, this bacteria is bad. We're starting to have a good sense of that. The second,
by the way, just so you know, just to double down on this, like there's a form of therapy, it's experimental, but it's called fecal microbiome transplantation, FMT.
I heard about this.
But we are finding now that you can take feces from healthy individuals that have good, gut biome and good bacterial counts. And if you put it, inject it into people that are suffering from a bunch of different diseases, it actually is looking like it's curative. So Parkinson's, MS, IBS, colitis. So it just goes to show you that
so somebody with good gut
there's
bacteria
poorly understood
into another person's intestines. Where do you put the poop?
No, through the bum.
No. You could do it there, or you can take a pill. So there's a little pill, and it's got the fecal stuff in it, and you swallow it, and it. Now,
so I want to eat somebody else's poop. You fix your poop.
I said it in a way so that we could see his reaction to in the bum, and Jason was like this. And so
he got excited.
But wait, how does this impact Uranus? That's what the audience wants to know, Freeberg. How does your Uranus impact your body?
Here's the other point I wanted to make, which ties to what Chamath said. This is really important, JKal. Yeah. So the gut biome is an ecosystem, like a rainforest. Mm-hmm. There are trees that grow, monkeys climb the trees, they poop, there's jaguars eat the monkeys, the trees grow because of the monkey poop. There's a whole ecosystem. All these organisms, all these microbes regulate one another and feed one another. And this is why probiotics do not work. Probiotics are single microbes, single bacterial strains or fungal strains that we put into a pill and we swallow it. And just because that microbe happens to have some beneficial effect, on its own in a petri dish, it does not survive in your gut biome, because it's like putting a house cat in a rainforest. The jaguar will eat the house cat. The house cat has nothing to eat, etc. It doesn't inoculate. Inoculate means that it survives, thrives, and the population grows. So when we take probiotics, it's just passing right through our gut. It doesn't stay there and doesn't change anything. And it turns out that the reason fecal microbiome, fecal transplants work is because you're taking the whole microbiome from someone else's gut and you're putting it in your gut.
The whole rainforest.
The whole rainforest. And so all the organisms that are needed that regulate one another, all of the small molecules that cross-regulate each other, they all go in your gut, and then they actually change your entire gut, and your gut becomes the rainforest of someone else's gut. And so if someone else has a healthy gut, meaning that
my anus can be your anus, Jason.
Wait, there it is. So we put our anuses together and then a monkey goes between them? And then the rainforest is... Well, let me ask two questions. The FDA has not approved any of this yet. When will the FDA be approving these treatments, et cetera?
There are a lot of clinical trials going on for fecal transplant. UCSF has a huge clinical trial for MS, as Chamath pointed out, right now, where they are actually doing fecal transplants on patients without MS into people with MS. And the early data of these sorts of treatments has indicated that there can be a very profound effect on the frequency of lesions appearing on the brain, which is one of the primary symptoms of MS. And so these organisms, we don't yet know why, but some of these bacteria...
When will we understand this? Is it a 5-year, 10-year thing?
There's a ton of startups. There's billions of dollars invested.
When will we know? When will we know and have like a game plan?
So it's already coming out. It's not like a binary switch. We're discovering new things. There's a set of companies that are discovering what are called small molecules. So they're finding what are the little chemicals that those good bacteria are making in your gut, and and can we turn those chemicals into drugs? And so they're trying to turn those into drugs. Other companies are saying, you know what, this is a set of good bacteria. Let's just put them in your body and figure out a way to get them to inoculate and stay. Other companies are saying, let's do fecal transplants. And other companies are basically just saying, let's change, this is what we do at Supergut, let's just change the feedstock for your gut biome, and you can actually evolve the rainforest into a different state by changing what you're feeding the bacteria in your gut. And there's certain molecules you can feed the gut bacteria, and then the populations will change into a more beneficial state.